In this segment, we're going to look at powers and roots. So powers and roots are really commonly used things in our math course and in math itself. They're just an abbreviated multiplication and the opposite of that abbreviated multiplication. So starting with powers or exponents, this is a repeated multiplication. So you're just multiplying something by something by something by something in that same number. So 2 times 2 times 2 times 2, 4 times 4 times 4, 9 times 9 times 9. As long as the same number is being multiplied. So here's an example of one here. We have 3 raised to the power of 4, which is equal to 81. So the base number is 3. So 3 is what we're multiplying repeatedly. We're multiplying 3 by itself 4 times, which is the exponent or power. And then the answer is just what that result is of that multiplication. So this is actually showing us 3 times 3 times 3 times 3. So this here is what that's asking, saying if you multiply 3 by itself 1, 2, 3, 4 times, what's the result? What's the answer? So let's take a look at a couple examples. Just have, again, powers and squares. Like I said, these are really common and you're going to see them a lot. And so it's going to become familiar with them, especially your powers of 2. So your squares and then your cubes are useful as well. So taking a look at this, 4 squared is asking us what's 4 times 4. And that is 16. 5 squared is asking us what is 5 times 5. Which is 25. 6 squared is asking us what 6 times 6 is, or 36. And 7 squared is asking us what 7 times 7 is, or 49. So that's what these are asking, is just what's times 7 times itself, 6 times itself, 5 times itself, 4 times itself. So squared is asking us to multiply a number by itself. In the case of the cubes, that's asking us to do it 3 times. 1 times 1 times 1. 2 times 2 times 2. 3 times 3 times 3. And 4 times 4 times 4. In any of these cases, it's not necessary to write out the expansion. I'm just illustrating what it is. You can go right to these results here, 16, 25, 36, 49. In this case here, 1 times 1 times 1 is 1, 2 times 2 is 4, times 2 is 8, 3 times 3 is 9, times 3 is 27, and then 4 times 4 is 16, 16 times 4 is 64. So there's our cubes. These are useful to remember, useful to work with and memorize, especially these ones here. We're going to see these a lot of squares. If you think back to the multiplication lesson, we talked about that line down the diagonal line down there. That was the multiplication chart. Those are those perfect squares. The other thing to note with these is that you can actually kind of think of these as area, and these ones here as volume. And that's where the word square and cube come from. So when we say square, you should actually picture in your head a square, which my drawing of a square is a little more rectangular. But if we have a 4 squared, it's asking us what's the area of a 4 by 4 square, and that would be 16. We'll call that, say, centimeters. So 4 centimeters by 4 centimeters, 16 centimeters squared. In the case of this, with the cubes, then you should actually visualize a cube. So there's a cube, and let's say a 3 by 3 by 3 cube, and that's actually what the volume of that cube is. And in this case here, it's that 27. And we'll say cm again. That says 27 centimeters cubed. So powers can be visualized, especially in the nature of cubes and squares. We have trouble visualizing beyond that, but cubes and squares are easy to visualize. So, there's your square. That means cube. So you're looking at a volume or an area, and you're just finding the dimensions of that square or cube, finding the area or volume of that square or cube. Now, if we take a look at the idea of roots, roots are just the kind of rearrangement of of an exponent type question. So we had our 3 to the 4 equals 81. So 3 times 3 times 3 times 3 is 81. What an exponent does is it asks you what's the base. So it's asking for the base. So if we take a look here, we have the 4th root. So here we have the 4th root of 81, and this line here, this little kind of check mark with a line extending over, it's not a division sign, that's called a radical. And so this radical here is asking us the 4th root of 81. So what times itself 4 times is 81, which is the 3, because 3 to the power of 4 is 81. So it's just a rearrangement of an exponent type question. So a couple examples here. When we're looking at the square root, there's our exponent. So the square root of 4, what times itself is 4. So 2 times 2, or 2 to the power of 2 is 4. What times itself is 9? Well, that would be 3. What times itself is 16? That would be 4. What times itself is 81? Well, that would be 9. So the square root of 81 is 9. The square root of 16 is 4. And the square root of 9 is 3. Note that I put a 2 here. There's a 2 here, but there's no 2 here. That is implied. So if there's no number there, it's a 2. You automatically assume it's a square root. Now in the next set here, these are cubed roots. So what times itself 3 times is that number, or what to the power of 3 is that number. In this case, we have to write the 3. So the 3 is there in each case. You have to write that number. If it was a 4th root, 5th root, 6th root, 7th root, what times itself 7 times is that number, we would have to put that number there. So in all these cases here, we have 3 times 3 is 9 times 3 is 27, so that would be 3. 64, well, 4 times itself 3 times is 64. I missed that equal sign there. And then 5 times itself 3 times is 125. And we can even do one more bonus one here. What's the square, or the cubed root of 1? And 1 times itself 3 times is 1. So you're just looking for the reverse. So 2 squared is 4. 9 squared is 81. 4 cubed is 64. So this is just an exponent question, rearranged, asking you for that base. And again, using that kind of analogy of a square, actually picturing that square shape, you have an area of 81 meters squared. What would be the dimensions of that shape? What would the length and width have to be on that? And in this case, it would have to be 9 meters by 9 meters. Same thing over here. If you had a cube and the volume of that cube was 64 meters cubed, what would the size of the different sides be? Well, you'd have to have 4 meters by 4 meters by 4 meters. And so you can again use that visualization idea a little bit with square roots and cubed roots.